why in the world are we hearing about people freezing to death in their cars in Pakistan? How does this even closely come to squaring with the fact that we are entering a time of unprecedented climate change and global warming? Well, hello, everybody, and Happy New Year. We're ringing in 2022 with a really interesting topic, brutally cold winters and our warming world. This is going to seem strange, I understand, because we are so much talking about, or we so often are talking about global warming. So a lot of you may be wondering, why in the world are we talking about it being cold or it being colder than normal? Well, you're not alone if you're having this feeling. As a matter of fact, you are in good or not so good company, depending on your perspective, of which I will abstain. But I will say that back in February of 2016, there was a senator here in the United States, one Senator James Inhofe. You may or may not have heard from him. He gained fame or infamy, however you want to refer to it, by bringing one snowball onto the Senate floor. So he was arguing against the fact that at the time, the year prior, scientists had declared 2014 the hottest year on record ever recorded. Now, he found this ridiculous because, as he said to his fellow senators, there's snow right outside. As a matter of fact, as evidence of this, I got this snowball. So what is this about global warming? And again, he very famously threw this snowball down the aisle of the Senate floor saying, "Catch this." Well, that's not too auspicious. I would argue, but it did give him lasting fame. 5 years after that, South Texas, mind you, Texas was hit with a major storm, and this storm brought ice, freezing rain, snow, and record low temperatures. And it was so cold, as to our title, brutally cold. And perhaps we can also say that the infrastructure was so underfunded. But it was so cold that the electrical grid was brought down and power ground to a halt, and millions of people in South Texas were left without power for days and some even weeks. This is something that we like to say, how can this happen in our country? Well, it does, and it did, and perhaps we're going to see even more of these instances, ironically, due to our warming world. Now, just last night, hundreds of people were stranded, much like those in DC or Virginia. Hundreds of people were stranded just outside of a resort outside of Islamabad in Pakistan. Now, to the latest count, 22 people that were stranded on that snowbound stretch of highway have died. 22. Now, some of them died from carbon monoxide poisoning by trying to keep themselves warm throughout the night, and some literally froze to death in their cars. So how in the world, we hear so much about Pakistan reaching record temperatures. We have heard that Pakistan may someday be uninhabitable and because of the heat. So why in the world are we hearing about people freezing to death in their cars in Pakistan? How does this even closely come to squaring with the fact that we are entering a time of unprecedented climate change and global warming? It just doesn't make logical sense to so many of us. And I'm hoping that we'll get an answer by the end of this show, that our great thinkers and scientists here can clear this up for us. How is it that in a time of record heat waves, are we also getting record cold waves? What gives? And I'm hoping that Peter, you may be able to clear some of this up for us.
Thanks, Regina. So you mentioned the famous Texas cold snap, which was pretty devastating. I mean, it was a relatively short term, but it was a very catastrophic event. And that was in February of 2021. Now, I look at the NASA temperature graphs, but I also look at the NASA temperature maps. And because they give a lot more information. Now, we're calling the problem global warming. It's a terrible term. In 2016, I remember John Holdren, who was the chief scientist for President Obama subsequently. I remember him saying that the better term would be climate disruption. We're almost getting into climate chaos, though, really, where the Arctic's concerned. So when I look at these maps, the highest temperature increase from pre-industrial on the NASA maps is about 12 degrees C. That's the biggest change. And then the lowest change to cooling compared to average is minus about 5 and 6 degrees C. So in February of 2021, those temperature changes were literally all over the map. Most of the United States was actually colder than usual, than normal, what I call normal, pre-industrial. I think what didn't get mentioned so much was Siberia was in a deep, deep, deep freeze, as cold as it gets on the NASA GIS mapping. But even more extraordinarily, below this huge cold area in Siberia, there was a vast, vast hot area in mid-Asia, Mongolia, going down to Nepal, reaching into China. And that was like 12 or 13 degrees above normal. So, so as you can see, global warming is not even, and these huge differences in the northern hemisphere. The southern hemisphere doesn't really get this because it's so much ocean. But in the northern hemisphere, particularly in the wintertime, but these events can occur in May right through to January, February. So there's a lot of months in which the northern hemisphere is subject to these extreme cold snaps. I'm no expert on this at all. It's way too complicated for my brain, so I don't know how the general public handles it, I must say. I sympathize. But what I've noticed is over the years, and this has been going on for at least 10 years, I have a map in 2010, which is almost as crazy as the 2021. These cold snaps that can occur, they're big regions that can occur in the United States and can occur in Russia, Siberia, and can occur in Europe. When I look at the NASA Arctic map, where you can looking down to the North Pole, and then you're looking down to Siberia and down to the United States and Alaska, what I've noticed is that these cold regions are matched above them on the Arctic with a very hot region. And this applies to both the cold regions in the winter, but as I say, could be earlier, in the United States, like 2021. It's very dramatic in 2021. And it can also occur in the Siberian ones, where you get a huge heating of the Siberian Arctic. And we all know about that. We all hear about that, you know, massive heating of Siberian Arctic. But below that, you can get this very cold snap in the Siberian Arctic. So, the research, and Paul will be able to go into this much better than me, the research that got our attention was research by Jennifer Francis, who was an expert watching in real time and doing some modeling the temperature changes in the Arctic, as I say, which are many, many years, they're all over the place. And she said, she worked out that this was having an effect on the Northern Hemisphere and was having an effect on producing these extreme cold events.
So for the uninitiated, Peter, when you refer to the Northern Hemisphere, can you kind of give us a breakdown of what that means? Are you speaking of Canada, Northern United States?
These extremes of heat and cold really range from Mexico right up to the North Pole. So it really is a very big region. The cold snap in 2021 reached down into Mexico and right up to Alaska. Now, this was February. It's supposed to be cold, but the maps show that it's far, far colder than it used to be.
Wow, that's really surprising for me. And thank you so much for clearing that up, Peter. It wasn't in my mind when you referred to the Northern Hemisphere that we're speaking of Mexico, which I know has also seen a great rise in their warming. So, and with that, extreme droughts in certain region. And I'm just wondering, Paul, is this what you would call weather weirding? What's going on here?
Yes, weather weirding, weather wilding, weather whiplashing in our climate casino. We mostly we're kind of focused on the warming events that are occurring because they're happening statistically. They're happening a lot more often. The cold events are diminishing in frequency and severity overall, right, on the planet. But that's, if you look at specific regions, then you can get a lot of very unusual things happening. So when we talk about the warming of the Arctic temperature amplification, loss of snow and ice, a darker region that absorbs a lot more sunlight, warms at 4 to 5 times faster than the average rise on the planet overall, then that warming can be from 2 main reasons. One of them, of course, I've mentioned already, is the Arctic darkening, so it's absorbing more solar radiation. But the other one is that the mechanisms that would keep cold air in the Arctic before are weaker. So I'm talking, of course, about the jet stream. And what's happening is often we'll get a massive spillage of cold air from the Arctic to far southern regions. So the idea that as you increase latitude, you get colder, that is being broken because of the behavior of the jet streams. They're becoming much wavier in the north-south direction, and such that the ridges of the jet stream can go right up to the North Pole and bring the temperature above 0 in the middle of the dark winter. Total darkness, North Pole going above 0 because the ridge of the jet stream goes all the way up there. Well, that cold air in the Arctic doesn't just disappear, right? The trend is that there's more and more warm air, less and less cold air, but it's often displaced and it falls down into the troughs of the jet stream, which we've seen can actually cross the equator. So it's possible that these cold outbreaks can go right down to the equatorial regions. And of course, when you get huge temperature swings in regions that haven't experienced it in the past, it can cause huge problems. Also, the timing. If you get a very warm air outbreak, for example, into deep into deep regions where say in northern hemisphere winter, boreal winter, and you get a warm air outbreak, in a certain region, then the plants can start budding, and then the killing cold comes and it kills all of the buds, and there's huge agricultural losses, for example. So there's a lot of non-uniformity in climate change on the planet, as we know. So regions, think of it as a topsy-turvy world where some of the huge amounts of cold that used to be up in the Arctic suddenly migrate down into the troughs of these jet streams and then sit over a region in the far south, causing tremendous cold, like whether it be in Texas, causing the power grid failures, whether it be in agricultural regions, right? So all of this climate disruption, the whole system is effectively rewiring. And I talked in the past about the idea that with a rapidly warming Arctic, as we head to a much warmer world in the Arctic, warmer region, the polar vortex tends to circle around the regions of cold. So with an Arctic much warmer, with lack of sea ice, etc., that polar vortex can be centered about, say, Greenland, as opposed to the North Pole. So it's shifting southward. So not only are the jet streams becoming slower and wavier, causing increases in frequency, severity, and duration of extreme weather events, including cold outbreaks, but the center of rotation of these whole jet streams seems to be shifting to being closer to being centered around Greenland as opposed to the North Pole. So this causes huge disruption to the climate system.
Yeah, it's really, I appreciate hearing what both of you have to say, and it's still kind of puzzling in a way. So let me give you an example. As you know, I live in New York City, and I love vintage photography. I love the old postcards, and I like history, and I like climate history. And I remember, I'm not sure exactly which year, but there was a winter that was so cold that the East River froze and people were able to walk from Brooklyn to Manhattan across the East River. Also, people used to ice skate in Central Park. They didn't have to go to Woolman Rink or the Trump Rink or whatever you want to call it, where they literally froze the ice so that people could skate. No, the ice used to freeze on its own. And as a matter of fact, we've just had our first snowfall. That's why I keep looking out the window. We just had our first snowfall yesterday. And in weeks prior, I mean, it was 50 degrees for much of December, which is crazy. So I'm wondering, is it better to think of this, to put it in the sense that it's like we have a warming world, but we have these intermittent blasts of cold rather than a steady state of cold, but these unexpected cold blasts?
Yes, I mean, think of the, we tend to think in a linear fashion. So we think of climate change, the warming rising like this, but now we're on a very sharp slope upwards. We've just passed sort of the kink of the curve, if you like. So we're heading to a much warmer world, but the cold air doesn't just disappear instantly. The cold air is being redistributed to regions that it wasn't in before. And this is I talked about the two mechanisms warming the Arctic. I mean, one is just the Arctic is getting darker, so it's absorbing more sunlight and warming internally. But the other thing is that because of the disruption of the jet streams, no longer acting as a barrier between the north-south, but huge excursions south of cold air, huge excursions north of warm air. It's just the cold blob, if you like, circling the Arctic is no longer staying in the Arctic. It's shifting down to much lower latitudes and parking there for long periods of time. So we can expect much more of this while we're still in this abrupt climate transition. But the long term is that we get less and less and less cold air as we head to a much warmer planet, a planet with no snow and ice in the Arctic, for example.
Thank you, Paul. So you said something, the redistribution of the cold air. And Peter, you had mentioned looking at the temperatures in relation to, I think you referred to them as temperature maps. And is this sort of what your strategy was, to look not necessarily the trend, but where the temperatures are changing in relation to their geography.
Yeah, that's right. Because when you look at these maps, I'm sorry I can't show them, but they are very, very dramatic. Probably what you mentioned was spring of 2018, Regina. That was an extreme situation. Practically three quarters of the United States, top to bottom, was at a temperature much colder than the average. There was only a little bit in California, which was actually warmer. And at that time, there were two huge areas of very hot Arctic. I'm talking 7 degrees higher than is normal. And they were in Alaska mainly, and there was another one again in Siberia. And I look at these maps over and over like this, and you definitely get the impression that the systems are trying to equilibrate. You get the impression that in actual fact, there's extreme heating in the Arctic is pushing down colder air, which is then hitting the mid so-called temperate latitudes. It definitely looks like that. And the appearance is very, very dramatic. Now, I should also point out, of course, that the northern, not only does the northern hemisphere warm faster than the southern, the continents, central continents, and we're looking at America, or I'm looking at America, and I'm looking at Siberia, they heat up even faster. And then, of course, the Arctic heats up the very fastest. So we have these huge differences. And the difference is greatest in the winter. The northern hemisphere heating is significantly higher in the winter than the summer. So everything is primed for this climate and weather chaos coming down from the Arctic and affecting the, as I call it, once temperate northern hemisphere. Spain had extreme record cold earlier on this year. This is happening. I think people are aware this is happening pretty frequently. But the point I want to make is here that yes, this is extreme cold, but it's associated with extreme heat in the Arctic.
Thank you. We have to change our thinking and understand that two things can be true at the same time, and two opposing forces can be true at the same time. It kind of makes me think, you've seen these things in offices where they have the 7 balls and you pull one and drop it and it hits the other, and then they bounce back and hit the other. I'm kind of visualizing it as that type of motion. And I'm wondering, Paul, do you think that that's an apt analogy?
It's a very good analogy. And I'll give another sort of idea, way to describe what's going on is, think of if the jet stream was mostly just from west to east, think of the length of the thread. Think of a thread covering the path of the jet stream. And the thread isn't, is going to be of a certain size when the jet stream is mostly going from west to east. And now think of all of the waves of the jet stream going to the far north and the far south. That thread is getting enormously longer. Now, each point that thread occurs, there's a clash between warm, humid air and cold, dry air. Okay, so when the jet stream was west to east, the extreme winds, whenever there's a big clash of temperatures, there's a clash of air pressure, right? The hot air at very high pressure in the ridges, in the troughs, very low pressure. Those high pressure differences over short spatial regions causes very, very strong winds. Okay, so now this thread is much, much longer. So many, many more parts of the planet are exposed to these clashes of temperature and clashes of air pressure and high winds. So I'll give you 2 examples. The Kentucky tornado outbreak was a classic example of that clash of warm air and cold air causing very, very high winds, lots of storm activity, lots of lots of mesoscale complexes, a huge storm front extending over thousands of miles, and this massive outbreak of tornadoes in the US. I'll also talk about the clash of temperatures in another case with Colorado. Okay, so, you know, wildfire, of course, and fires we can expect to happen more often in areas that are extremely dry and extremely hot. But when you combine this clash of temperatures and get extremely high winds generated, I'm talking about 100-mile-an-hour plus winds, and the Rocky component, the Rocky Mountain component, the downslope wind is also in there, in a factor in the equation. And when you get these, you know, category 2 hurricane, category 3 hurricane winds, and you get sparks and you get the fire generated, then you can see what happens. Like we had an urban firestorm in Colorado. Believe it or not, many of these fires were started inside the houses because 100-mile-an-hour winds carrying embers and cinders from the fire, they'll find their way through any crack under a door or any open window, and the embers are carried right inside the structure and can start the fire burning from within. And as you saw of these neighborhoods, there was total destruction of all of the houses. I think one house was standing in one image I saw. These type of fires are new. When you combine extremely high hurricane level winds with fires, there's no structure that can really withstand this type of thing. It's like the firebombing. We haven't seen this for quite a few years. We saw it in World War II, for example, the firebombing of Tokyo, right? The fire itself can then generate such large convective uplifts that it can generate enormous winds, and it basically can incinerate everything. You know, it looks like a nuclear bomb hit, basically. So we experienced this effect in Paradise. And not only that, I mean, the very, very high winds, they just knocked over live power lines. That caused the spark, you know, which triggered the fire, these fires. And that happened in Paradise, California. It burned down, that town burned down 2 years ago in 2018. Similar thing happened in Lytton, British Columbia this last summer. And now, of course, in Colorado, you know, we're up to maybe 1,000 structures were destroyed. It looks like almost nothing remains except for some scorched trees, you know, because the fire, the only thing to burn in that region, I mean, people have grass on their lawns, some shrubs, but it was all of the structures that burned. And a friend of mine was saying, well, why didn't the homeowners just stay, you know, and bring out their hoses and make sure their house was all wet and have a metal, you know, that type of thing. But these sparks being blown at such high speeds destroy the structure. The only thing I see that could maybe be used is, I've seen some instances of people buying large mylar heat reflective sheets, you know, and when their house is threatened maybe by a wildfire, cover their entire house with this highly reflective sheet. And some people have actually done that to save houses in that situation. But, you know, it's really a new thing that we have not seen outside of bombing in wartime. You know, these urban conflagrations. So again, it's all connected to this this disruption of the jet streams, this disruption of weather patterns and around the world. It's all because of climate change. Climate change is too kind a term now, as Peter said. Climate disruption, climate chaos, climate mayhem. You know, this is the world that we live in now. I mean, we need to all recognize this. I'm talking about the public needs to all recognize this, and we need to do what we can to reverse it. I mean, we're going down as a society. I mean, these things are, you know, financially, they just, like, how, you know, I mean, eventually countries will be bankrupted. The US will eventually be bankrupted by extreme climate events.
Peter has his hand up.
I just got one quick really interesting, extremely significant, particularly this talk, research that was just published. And scientists have now linked the loss of sea ice and the feedback, the heating, extra heating of the Arctic with these Western United States fires. So now this is yet another factor which is driving these fires to be, as Paul describes so well, so extensive. The burning is so severe. It's just going to get worse. I agree with Paul. The one thing that the IPCC's recent assessment really made was that wildfires are regarded as one of the extreme weather events by the IPCC. So all of these extreme weather events are getting rapidly worse, more frequent, all of them, droughts included. And the IPCC said that is due to our greenhouse gas emissions, and they will get worse. And the more our governments continue to act in the most evil, criminally way imaginable, which is not only to permit and support the fossil fuel industry, which is causing all this mayhem, they're actually subsidizing the fossil fuel industry still. And my heart goes out. I feel anguished for the wonderful young people, right? Like Greta and Vanessa and Roberta in the United States. It's just horrible. They know what our governments and industry are doing to them. And they know firsthand that the governments are writing them off. They're bringing court cases, and all the governments, I am shocked how every single government in the world has fought these cases brought by these young people in order that they might have an earth worth living on. So yeah, it's everything is going down, and everybody has to wake up.
Well, thank you, Paul and Peter, for those final thoughts. They are very sobering, and it's very hard to have, it seems, to have a sanguine conversation when we're talking about the issue of climate change. We want to leave you on a positive note as much as we possibly can. So it is a new year, right? It's a new start to a new year, and it's just perhaps an arbitrary marker of time, but it doesn't have to be completely arbitrary. You and I and we can all make up our minds to do more, to make changes in this year, to advocate for the youth of the world, to make this planet one that can be lived on in the future. So let's see if we can all get together and try to make that a reality. So whatever it is that you do in your own little way, do it, recognize it, feel good about it, encourage your friends to make change in this new year. And if you haven't liked and subscribed to our channel, please do. Share this video with someone else and keep talking about climate change. Thank you very much. And once again, Happy New Year.